where is, there it is. And we are working on, remember we were looking at systems of equations and matrices. We were ready to begin our discussion on Cramer's rule, and I need to do a little writing for that before. So let me get to my paper. Cramer was a very prolific mathematician, and he did lots of work, significant mathematical work, but the one thing he's remembered for is something he didn't consider that significant. It's called Cramer's rule. Cramer's rule uses determinants to solve systems of linear equations
instead of using elimination or substitution.
So we now have a third method of solving linear systems. We saw elimination and substitution the last time. Now we're looking at Cramer's rule. What Cramer discovered was that the value of the x variable will equal d sub x divided by d. Or what's d sub x and d? We'll discuss that in a moment. If he's trying to find the value of y, it would be d sub y divided by d. Whatever the variable is, the subscripted determinant is what's on top. The determinant of the coefficient matrix is what's on bottom. And to illustrate this, that's where we're going to look at number 13?
Well, number 13 looks like something you could do elimination on pretty easily. Just multiply one of them by -1, but we're not going to do elimination. We're going to use Cramer's rule.
And 4x plus 2. First of all, do you all agree that this system could certainly be solved using elimination? We already have the same coefficients on x, 4 and 4. All we'd have to do is multiply through by -1 so that it have opposite signs, and we could eliminate x. But we're not going to use elimination. We're going to use this problem to illustrate Cramer's rule. Cramer's rule is nice because there's no algebraic manipulation. It all involves calculations involving numbers. And you know something? Yes. The first thing that Cramer did was find the determinant of the coefficient matrix. He made sure that the like variables were aligned. He made sure the constant terms were on the other side of the equal side. And then, to find, he denoted the determinant of the coefficient matrix with just a capital D. Well, we're only looking at the coefficients. The coefficients for x are 4 and 4. The coefficients for y are 5 and 2. And we remember how to find a 2 by 2 determinant. Remember, you multiply 4 times 2 is 8 minus multiply 5 times 4 is 20. So the determinant of the coefficient matrix is -12. And we'll set that number aside. We better make sure we got this d value correct, because we're going to use that d value to find x and y. The next determinant he found, he denoted d sub x. D sub x is the determinant you get when you replace the x column. The x column has to be replaced with the column of constants. So instead of a 4 and a 4, we're going to have a 1 and a 14. The x column is being replaced by the column of constants. The y column stays at 5, 2. Put an equal sign. Oh, yes. D sub x. is equal to. It's the determinant you get when you replace the x column with the column of constants. So we multiply 1 times 2 is 2 minus multiply 5 times 14. Is that a 70? 2 minus 70 is negative 68. And for every variable appearing in the system, he found a determinant. So now we find d sub y. D sub y, that's the determinant you get. You go back to d. The x column goes back to 4, 4. You're only replacing one column at a time. The column being replaced is the subscripted column. So the y column is now going to be replaced with 114. So in place of that 5, 2, we have a 114, and we multiply 4 times 14 is that 56, minus multiply 1 times 4 is 4. 56 minus 4 gives me 52.
Cramer's rule is nice because maybe if your answers are going to be messy fractions, it doesn't have any impact. You know?
If we get a messy x equals a fraction, we don't have to plug it back in to find y. It's all simply numeric calculations. And Cramer said x is equal to d sub x divided by d. So d sub x was negative 68 divided by d is negative 12. Oh, let's see. Well, 12 doesn't divide evenly into 68. I was expecting these things to be integers. Are you sure I didn't miscopy the problem? Oh, okay. Negative divided by negative is positive. We can cancel what? A 4? We can cancel a 4 above and below. 68 divided by 4 is going to give me 17 all over 3. That means that these two lines intersect where the x value is 17/3.
If you would use an elimination or substitution, you now had to plug 17 over 3 in for x to get y. That would be messy.
Okay, now y. Y is equal to, let me push it up a little bit, d sub y divided by d. D sub y was 52 divided by 12.
Negative 12.
Negative 12. Oh. Well, we can cancel. I think there's another 4, isn't there? Yeah. 13. So a negative 13/3. 52 divided by, well, first of all, positive divided by negative is negative. 52 divided by 4 is 13. 12 divided by 4 is 3. So negative 13/3.
Notice how even though the answers are messy fractions, you don't actually do any work with the fractions. But that's the nice thing about Cramer's rule. You don't have to plug in.
Do we have any programmers in here? This process is very easy to program. It's all numeric. It's all numeric. All you do is you feed in the coefficients and constants into a matrix and let it do the work for you. So just multiply minus multiply. I remember having to write a program to solve linear systems once, and that's what we did. We used Cramer's rule.
What was it? X value
17/3.
I'm not going to put the comma down there. If you put that comma in the bottom of the fraction, it might count it wrong.
It'll probably count it wrong.
The comma should go between, so comma, and what is that?
Negative 13/3.
Don't do that. Oh, wait, no. Don't do that. It'll count it wrong for sure. Right arrow to get out of that fraction. Close the parentheses.
So now, in addition to elimination and substitution, you have this new method of solving linear systems, and there's no combining like terms. You'll notice whether if you're using substitution or using elimination and then substituting back in, you still wind up with like terms. You have a linear equation. You got to solve for that one variable. Here, it's all numeric. Any questions there? Let's look at number 14. It's another system. Negative 3x plus 2y is equal to 2, and 2x plus 8y is equal to 120. Okay. So, first thing, the determinant of the coefficient matrix. The coefficients for x are negative 3 and 2. The coefficients for y are 2 and 8. Multiply negative 24 minus multiply 4, give us a negative 28. And remember, that's what you're dividing by each time. So you better make sure you got this d value correct. We then find d sub x. What numbers am I going to write right here? 2 and 120. We're replacing the x column with the column of constants. 2 and 120. The y column stays that 2 and 8. So we multiply. That's 16 minus multiply. That's 240. So is that a negative 224? Negative 224. And we have another variable. It's the y column, so we have to find d sub y. What numbers do I write here in the first column? That's correct. You go back to the original values for x. The only column you're replacing is y. So negative 3, 2 is x. The y column, that's the column that we replaced with 2 and 120. So we multiply, that's a negative 360 minus multiply 4. That's giving me negative 364. I didn't remember that these answers were so messy. I'm glad we're using Cramer's rule.
Yeah, but I don't think we have a fraction. I think this works out without
a
fraction.
Okay. Let's see. Now, Cramer said x is equal to d sub x divided by d. So that's a negative 224 divided by negative 28. And is that a 8?
160 and 64, yeah.
Okay, so a positive 8. That means these lines intersect where x is equal to positive 8. We do the same thing for y. Y is d sub y divided by d. D sub y is a negative 364. D is still that negative 28. And is that going in evenly?
I'm thinking 280 and 64.
Hmm?
13.
13.
Oh, why don't I
I was
going
going to say open up the calculator. I can tell you it's going to be positive, okay?
Oh, let me clear all of that. So, second quit. So, 364. Thinking it's 13.
Yeah, you're right. Look at
No,
that.
it's 3 times
So
28 is
those two lines
84.
intersect
Yeah.
at the ordered pair 8, 13. Any questions there? Of course, if you're working this problem at home and you use elimination, I suppose there's no way to get around it. I remember seeing some problems in a test bank once. Okay, here's the system. What's d sub y? You know something? Those type of problems, they force you to know Cramer's rule.
Yeah.
They don't just, you can't just decide, I'll use elimination to find d sub y. No.
But this one wouldn't be too bad using elimination because
No.
you don't wind up with any fractions of the answer.
Look at that the second equation. What I would do, if you wanted to use substitution, I would divide through by 2 to get a 1, 4, and 60 on the other side. Then just solve for x. So that wouldn't have been too bad. Any questions there?
That is called. Oh wait, let me
have to
touch
type in
in
the
and make
answer.
sure I got the right answer. What was it?
8, 13.
Parentheses 8, comma 13. Close parentheses equal.
Any questions there? And there's some word problems I want to look at. Start with number 16
Yeah, we'll come back to number 15
later.
yeah. Number 15 isn't hard. It's just not a good. It doesn't show the.
I didn't like that terminology of the 1 point and the free throw, what have you. So, number 16. A woman bought some large frames for $11 each and some small frames for $7 each at a closeout sale. If she bought 15 frames for $121, find how many of each type she bought. And that reminds me, Tony, on the day after Christmas, we're going to have to be at Walmart. I don't care where we are. We have to go to Walmart and get some closeout Christmas lights.
Oh, I thought you were talking about frames.
No, but
I'm assuming these are picture frames.
what sort of frames is she buying? Picture frames? Maybe she owns a gallery or something. Or maybe she's an artist and she wants to frames just to
She might be a grandmother and wants to put all her grandchildren's pictures on the wall. I mean, buying 15 of these frames, whatever frames, it seems like I don't think it'd be glasses.
Probably not.
15.
Yeah. It's certainly not at $11 and $7 each.
Okay, so we're now going to show you all of these word problems have a pattern. They're going to set up, but your goal is to come up with the 2 equations. You've got to come up with 2 equations that look like this, and then it's up to you. Elimination, substitution, Cramer's rule. Cramer's rule works really good if you think there might be fractions in the answer. And you want to avoid.
Look back at that problem, number 16. What are we looking for? What are the unknowns here? I claim that there are 2 unknowns. We know she bought some large frames. We know she bought some small frames.
This little thing gives you a hint on the first thing you're looking for.
But what are the unknowns?
Yes.
I was going to ask, so like, we're looking for frames, but that tells us we're not looking for a fraction. So that can
Exactly.
That's right.
There won't be. You got ahead of me. That's what I was going to say. Is there's not going to be fractional answers, so I'll use elimination on these because that's my favorite thing.
But
you
you're
wanna
not
use-
the one
I know.
doing it, Tony. I claim there are two things we don't know. The number of large frames she bought and the number of small frames. I'm just going to assume for the sake of argument that these are picture frames that we're looking at.
It really
And
doesn't matter.
I'll say the number bought.
He's making a table.
I'm
and he'll do
summarizing
like
my
that on all of them.
I'll summarize the information on a table to the extent that I can, to the extent that it's possible. The number of large frames, we don't know how many she bought. We don't know how many small frames she bought. I'm going to use an X and a Y. She bought X small frames, she bought X large frames, and she bought Y small frames. Let's go back to the problem. Let's continue trying to digest this information they gave us. The selling price or the price.
Okay.
I'm going to make the large frames were $11. The small frames were only $7. So I'm labeling a column for price. One is $11, the large frames. The small frames were $7. But they gave us more information as well. What else did they give us?
Totals.
Oh, they gave us some totals. She bought a total of 15 frames. Switch back. She bought a total of 15 frames. Well, she bought X large and Y small. If we total the number of large and small frames, it had better equal 15. What did they tell us about the money? We have a column involving money here. So, what did they say about money? Oh, she spent a total of $121. So if we're going to here, did I give it back?
You gave it to me.
Okay. Go out there and catch her. If we total up all the money she spent, it would equal that $121. Is that what they said, 121, or was it just 120? Notice how many times I keep going back to the problem, making sure, yes, she has a total of 15 frames, and they cost $121. So if you total all the frames she bought, it should be 15. If you total all the money that she spent, it should be $121. When solving systems of linear equations, your goal should be to have the same number of unique equations as variables. We have two variables, so we need to have two equations. Well, one equation falls out very quickly for me. If you add up the number of large frames to the number of small frames, that had better give us the 15 frames that she bought. So the first equation, x plus y, is equal to 15. Now let's think about how it works when you're buying multiple items. Suppose she bought 3 large frames. Suppose she bought 3 large frames. How much money did she spend on those 3 large frames? $33. My point is that to determine the amount of money she spent on the large frames, you take the cost per item times the number of items. So 11 times x. 11 times x, that's all the money she spent on the x large frames. Let's add to that the amount of money she spent on the y small frames. How much money did she spend buying those small frames? Each one was $7. She bought Y of them, so 7Y. This is the money 11X is the money she spent on the large frames. 7Y is the money she spent on the small frames. Add them together, that better give you the amount of money she spent total, $121. Any questions on our logic there? Any questions? Because at this point, it's just solving a system of equations. We can use elimination, substitution, or Cramer's rule. I'm going to use elimination just because I prefer elimination. And, okay, we have the like variables aligned. That's good. But we need the same coefficient but opposite signs. We can multiply the top equation by negative 11 to get negative 11x. But I think I'm going to eliminate y. Why? Because I'll be multiplying by something that's, I'll be multiplying by a negative 7 rather than a negative 11. Y'all follow my logic? I'm going to multiply through by a negative 7. That'll give me, the new equation will be negative 7x, and then negative 7 times y will be a minus 7y equals negative 7 times 15. Is that a negative 105? I don't think it's a negative 85, isn't it? It's a negative 85. I'll recopy the second equation. 11x plus 7y is equal to 121. Let's add the two equations together. Adding the two equations together, negative 7x plus 11x, that gives me 4x. What's going to happen when we add the y terms together? Okay, that's why we did that. That's why we multiplied by that negative 7. That negative 7. We wanted to get rid of the y terms. And now we have a negative 85 plus a 121. That's going to give me a 15 and a 121. Is that a 36? Negative 85 plus 121 is giving me 36. Where is that then? Negative 85 plus 121 gives me 36. So what's x going to be? And so we know now x is equal to 9. X is equal to 9. What's y have to be? She bought a total of 15 frames. So what does y have to be? You can go back to that original first equation, x plus y equals 15. If you can't just say, well, that's 9, you need 15, so this has to be 6. Plug in the 9. 9 plus y equals 15. Subtract 9. 15 minus 9. Sure enough, that gives me 6 small frames. So she bought 9 large frames and 6 small frames. Any questions on our logic there? 9 small and 6 large. Wait. 9 large. Oh. She bought 9. Okay, put it on this copy. 11, 7, 15, 11, 7. Okay, where's my mistake? Oh my Lord, that is a 105. Negative 7 times 15, and y'all let me go on and not say anything? That was 105. Well, that's really going to mess things up, isn't it? It's a good thing this isn't a test question. That was a negative 105 plus 121. I was just convinced she was going to get 9 of those things. Negative 105 plus 121, that should have been 16. So what are we getting for x? 16 divided by 4 is 4. And how many of y'all caught that? Brandon? No? Oh, that's a good... any future teachers? Okay, here's a good teaching tip. If you make a mistake, you blame it on the students for not spotting it, okay? So that's a good teaching strategy. Subtract 4, so what are we getting? Okay, so, well, our boss just texted us. That's why Tony stepped outside. And so once he gets back, I'm going to let him take over. I'm really making a mess here. 4. My brain is already on Thanksgiving break. So wait, let's come back over here. Oh, 4 and 11. Any questions there? After we were saying these work out nicely, this information summarizes so nicely in tables. Yes. Say it again. You know something? I'm going to rework this one. I'm sorry, okay? 16. We had large frames and small frames. Okay, wait a minute. So we said large frames, we'd had X of those, Y small frames. The price per frames for large was $11. The price for the small was 7. Is that what it said? 7? 7, yes. Okay. And then they have to give you some totals. So when you're summarizing information on a table, realize that's the quantity. This is how many she bought, and this was the cost. If you total up all that she bought a total of, was it 15 frames? If you total up all the money she spent on those frames, it was $121. One equation falls out quickly. X large frames plus Y small frames had better equal a total of 15 frames. So that's where we got that X plus Y equals 15. The second one, cost per item times the number of items. That'll give you how much money she spent on the large frames. And I'll go back to, if she bought 3 large frames, 3 times 11, she spent $33 on the large frames. So you go cost per item times the number of items. That 11x is the total spent on large frames. That's all the money she spent on large frames. plus, let's add in the money she spent on the small frames. You go the cost per item times the number of items. 7 times y, 7y, that number there is the total spent on small frames. And if we add that up, the money spent on the large frames plus the money she spent on the small frames, it had better give you that 121. And both equations involve x and y. We found an equation for the quantity. We found an equation for the cost. There are two variables. You need two unique equations. And then we said, okay, we were going to eliminate y by making that a -7. So we multiplied through by -7 to give me a -7x minus 7y equals a -85. I don't know what I was doing. That made me mark that out and make it a 105. Or did I say 115? What did I write? Whatever it was wrong. And then an 11x plus a 7y equals 1. Pardon me? It's 105. You're right. It's 10. I did it again. Goodness. Thank you. It is a -105, not a -85. And then that's a 4x -105. That's a -105 plus 121, which is 16, divided by 4 to give me x equals 4. And if x is 4, 4 plus what gives you 15? 11. Did I answer your question? Okay. Number 17. The cost to attend a movie is $8 for adults, while children are admitted for $5. If a movie was attended by 62 people who paid a total of $358, how many adult tickets and how many adults and how many children attended the movie? The first thing you have to do is you read that, you have to decide what are the unknowns. Well, we don't know how many adults attended the movie and how many children attended the movie. So number 17, I'm going to try to summarize the information in a table. We don't know how many children attended the movie and how many adults. Adults and children. And this is the quantity, the number of tickets sold. I'll let X be the number of adult tickets and Y be the number of children tickets sold.
On this one, it clearly states right out here the unknowns. It gives it both, adults and children. Whereas on that other one,
they gave us some dollar amounts also. They told us that the cost for each adult ticket is $8, but children tickets only cost $5. Let me give you all a moment to figure out where are we going to put those totals. Once you have this made up like this, let's look at the totals. They say a total of 62 people attended the movie and they paid $358. So 62 and 358. The way I'm summarizing it in the table, 62 and 358. The way I'm summarizing it in the table, 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 the way I'm summarizing it Where do you think I'm going to put that 358? Where do you think I'm going to put that 62? Those are the totals they gave us. What do you think? Where will I go? First of all, the 62 tickets. They sold 62 tickets. 62 people attended. Where should I put 62 on this table? Underneath the quantity. I agree. 62 people attended the movie. What about that $358? $358. Where am I going to put that total? Under the cost. We have two variables, so we need two unique equations. Give me one of those equations. Okay, the number of adult tickets plus the number of children tickets had better equal 62. So x plus y is equal to 62. What about the second equation? We need two unique, when I say unique equations, once you get one, you can't decide, well, my second equation, I'll just multiply through by 2 and get 2x plus 2y equals 124. You can't do that. It has to be a unique equation, a different equation. So, okay, 8x. The adult tickets cost $8 each. There were X tickets sold. So 8X is all the money they spent that they got from selling adult tickets. Plus, what else? 5Y. That's all the money they took in from the Y children tickets. It's the cost per item times the number of items. Here's all the money from the adult tickets. Here's all the money from the children tickets. Combined together, that's a 5. This is a 5. Combined together, that had better give us 358. Well, I think I'll use elimination. What variable do you think I'll eliminate, x or y? If I want to eliminate x, what am I going to have to multiply by? A negative 8. If I want to eliminate y, what will I multiply by? A negative 5. Which one do you think I'm going to do? Okay, so I'm going to multiply by negative 5. So, we're distributing through the negative 5. That's going to give us a negative 5x minus 5y equals, is that a negative 310?
Mm-hmm.
The second equation will stay as is. 8x plus 5y equals 358. We add the two equations together. What's that going to give us? Okay, negative 5x plus 8x. That gives me the 3x. What happens to the y's when you add them? They cancel out. Let's see if I can do this correctly. Negative 310 plus 358 gives me a positive 48. And then we divide by 3 to give us x equals 16 adult tickets. There were 16 adult tickets sold. So, what does y have to be? We know x plus y equals 62. So 16 plus y equals 62. Is that giving me 46?
Oh, I punched in the wrong number. If there were 62 tickets total,
There were
then 16 and 46. They could do that just logicking once they know that, rather than algebraic.
Any questions there?
So 16 adult, 46 children. Let me plug it in. 16 adult. Oh, come on here.
Right. There you go. Just put them down.
Oh, okay. 16 adult and 46 children. Tired of waiting.
So what did you do? Didn't go down.
No. I'm going to go see if she's not been there.
Okay.
Oh.
Oh.
Why do these instructions say that?
Just ignore those instructions.
We're not using Cramer's rule.
We're not using Gaussian elimination. But we're going to use elimination, substitution, or Cramer's rule. Mike works a total of 54 hours per week at his 2 jobs. He makes $7 per hour at job A and $8 per hour at job B. If his total pay for 1 week is $396 before taxes, then how many hours does he work at each job? I remember one time he worked a total of 98 hours per week, and that was just such a depressing problem here at the end of the semester. And that was the last problem I was working. One time he was working 104 hours per week, if I remember correctly, at these 2 low-paying jobs. But here it's only 54 hours per week at least. What are the unknowns? Tell me what I'm going to write out. What are my unknowns? Switch to the paper. This is number 18. First thing I do is I identify what I don't know. Well, he has 2 jobs and we don't know how many hours he worked at those. So I'll say
boxes down there sort of
job A and job B. I'll say he works X hours at job A and Y hours at job B. I'll say the number of hours worked. And
what's the next column going to be? What numbers are we going to write there?
I got to hear you. Okay. For job A, Mike gets $7 per hour. For job B, Mike gets $8 per hour. So this is the pay per hour. That's how I'll label this next column. I remember once there was a student. It was a young student, and they decided, well, he should only work at the $8 an hour job. He should work all 54 hours at the $8 an hour job. Why would he work at the $7 an hour job? It was a young student, and I suppose they had never been in the workforce. In most cases, you can't tell your boss, I'm going to work this many hours, okay? So really, that's not really an option, I suppose, because surely if it were, he'd want to work for the higher paying job. But let's go back. What else do they say?
What are the totals going to be?
What are the totals going to be?
Do y'all notice that these sort of follow the same pattern? Okay.
Okay, he works a total of 54 hours a week. Where is that 54 going to go? Switch back. Where will the 54 go? Okay, under the number of hours worked. He worked X hours at job A, Y hours at job B. If you add them up together, it'll give you 54. What about that 300? How much was it? 396. Where's that total going to go? Here? Right here. Oh, okay. Jonah was just going to agree. It's not 900. I wish Mike were making that much money. What is it, 396? And y'all call out the equations for me. How many equations do we need? 2 because we have two variables. So call out one equation. Okay. And the second equation. Seven x. Okay. Equals 7x, that's all the money earned at job A, plus 8y, all the money he earned at job B. Add those two together to get $396. Y'all tell me what y'all want to do. Substitution, elimination, or Cramer's rule? I'll let y'all decide. Elimination, what do you want to eliminate? Do you want to eliminate x, or do you want to eliminate y? Eliminate the x. To eliminate the x, we have a 7 there, we have a 1 there, so we're going to have to multiply by -7. That gives me a -7x minus 7y equals 50 times 7 is 350. 4 times 7 is 28, so I'm getting a -378. I probably don't trust me there. My brain's already gone on Thanksgiving break, thinking about what lights can I put up next? What can I light up next in our backyard? Okay, then we have positive 7x plus 8y. Oh, this is working out nicely. Y'all see why I'm saying this is working out nicely? The x is -7x plus 7x is gone. Add the y terms. What are you going to get there? -7y plus 8y. 1y. So we already have y by itself. -378 plus 396. I'm getting, is that 18? So we're getting 18 hours at job B. So he works 18 hours at job B. So how many hours is he going to work at job A? Remember, it has to total up to what? 54. So 54 minus 18, is that giving me a 36? So unfortunately, he's working more. The amount of hours he's working is more at the lower paying job. Any questions there? So, at job A, he worked 36 hours. At job B, he worked 18 hours. As you're going through this, suppose I'd been right here. Suppose I'd gotten a -18. What should that have told me? If I'd gotten y equals a -18 hours, what should that have told me? There's something wrong. You can't go to work and work -18 hours. For these quantities that we're looking at, none of them should be negative. Okay? Now we'll go back to number, is it 15? That must be 15. There's nothing wrong with 15. I just didn't like the wording here. A basketball player scored 14 times during one game. She scored a total of 22 points. She got 2 points for each 2-point shot and 1 point for each 1-point shot. In other words, for each free throw. So, how many 2-point shots did she make? How many free throws did she make? This is number 15. So we want to know how many 2-point throws did she make, how many free throws did she make. Those are the unknowns. So I'll say 2-point shot and free throws. We don't know how many of those shots she made, so we'll say she made X 2-point shots and Y free throws. This is the number of shots. And we know something else. We know that each 2-point shot is worth 2 points. What about each free throw? How many points is that worth? 1. So that's the number of points per shot. Still just reading, dissecting the problem. Okay. The basketball player scored 14 times during one game. Where's that 14 going to go? Here's my paper. Where do y'all think I'm going to put the 14? Okay, the number of shots. She scored 14 times total. Oops. And there better be some more another total. Let's keep reading. Notice how many times I switch back to the problem, rereading it. She scored a total of 22 points in this game. She scored 22 points. Where is that going to go? Okay, the total of the points. She scored 22 points in that game. We have 2 variables. How many equations do we need? 2. Okay. Give me the first equation. Okay. X plus Y is equal to 14. She made X 2-point shots. She made Y free throws. So if you add those together, it better give you the 14 times she scored. We need another equation. What will it be? Okay, so the 2-point shots were worth 2 points each. The free throws were worth 1 point each. So 2 times X, that's all the points she got from those 2-point shots, plus points per shot times the number of shots. 1 times Y, that's just Y, is equal to 22. And that's a plus right there. Well, I'll let y'all choose elimination, substitution, or Cramer's rule. Which one do y'all want to do? Okay, do you want to eliminate X or do you want to eliminate Y? Okay, well, Y already has the same coefficient, 1 and 1. Well, we need opposite signs, so one of them has to be multiplied by -1. Which one do you think I'll multiply through by -1? Okay, that's the one I'm going to do. Multiply by -1. So we get a -1x minus y equals, what's that going to give us here? -14. We still have the 2x plus y is equal to 22. That squeaking door is sort of annoying. Okay, so we have -1x plus 2x. That gives us 1x. The y's disappear. What are we going to get here? -14 plus 22 means that she made 8 2-point shots. So she made 8 2-point shots. Free throws, she's just standing still. That's why they're standing there at the line. So that's why they're only worth 1 point each. So what will y be? It needs to add up to a total of 14. 8 plus what gives us 14? I agree with 6. Any questions on our logic there?
8 2 points and 6 free throws. Oh, they're asking them one at a time. So 8 2-point and 6 free throws.
Actually, it's 85 free throws. Negative 85 free throws. That's a joke. You wouldn't get it.
Oh, okay.
Any questions there? Move that camera. That calculator. I think we've done it all, haven't we?
We have 100 on this assignment.
Oh, so we have done it all.
Any questions? And again, you could have used elimination or substitution or Cramer's rule on these.
I should have used elimination on one, substitution on one, and Cramer's rule on one.
But elimination is the best. So
know.
unless you know for a fact,
Well, actually,
there might be some fraction.
and remember, we don't use strict elimination. We use a combination of elimination and substitution. We eliminate to get one, then we substitute to get the other one. Any questions there?
Wow.
Okay, so stop recording.
Okay.